Hey, good morning. So I'm going to go over Lewis structures and how basically we're going to draw the shape of a molecule, which will give us insight into the polarity of the molecule and some physical properties of the molecule, okay? So I'm going to go ahead and share my screen. Once again, we're talking about the Lewis structure for molecules, okay? And what we do is, hold on, I'm trying to get this to work, is we draw, we take some basic steps, same steps to draw the shape of the molecule. Now let's do a little bit about, I'm going to start writing here. So we're going to look at Lewis structures for molecules, okay? And I'm going to go through the steps as to how to draw or determine what this Lewis structure is going to be. Now, make sure, please, that you realize that these are for molecules, and molecules are covalently bonded, okay? What I mean there is we do not draw Lewis structures for ionic compounds. We draw Lewis structures for covalently bonded molecules, okay? There's a difference there. So we're going to reserve the word molecules for something that's covalently bonded. The first step, there are steps you will take to draw the structures. You will determine the number of electrons, and these are always just the valence only, available for bonding, okay? All right. You will then determine the central atom. It is never hydrogen. Hydrogen is too small to be in the center of a molecule. Will never be hydrogen. Okay. Is the least, the least electronegative element is the center. The least electronegative element is typically in the center, okay? And it's usually always the first element written in the compound is typically the least electronegative element. So if we're looking at SO3, S is going to be in the center, okay? If we're looking at NH4, N is going to be in the center, okay? Usually the first element in the compounds. We will then arrange the atoms, connect atoms using electron pairs, and we will then satisfy the octet for outer atoms and central atom, and we will make multiple bonds if necessary. Okay, it all sounds kind of confusing, and it often is confusing to students in the beginning, all right? So let's just look at a simple example here. What does Mr. Murphy want to start with? Let's start with carbon tetrachloride, real easy, carbon tetrachloride. Now, okay, so first of all, I need my formula. There's my formula, right? And I need to determine how many electrons are available for bonding. Now, basically, you want to think about it like this. All of the elements are going to donate their valence electrons okay, to the whole of the compound. And the compound, and we are going to arrange those electrons however we want. So carbon here is donating 4, right? There's only 1 carbon. He's got 4 valence. He is donating them to the good of the whole. Chlorine has 7 valence, but we have 4 chlorines, so that gives us a total of 28 electrons. If we add those up, we've got 32 electrons available for bonding within the carbon tetrachloride molecule. So step 1 we just did. We added up our electrons available for bonding. Step 2, determine what the central atom is. Well, it's usually the first element, unless that first element is hydrogen. The first element here is not hydrogen, so I'm going to put the first element in the center. Again, I'm going to arrange the other chlorine atoms around. All right. Now I've got 32 electrons available for bonding. My goal is to satisfy the octet for all atoms. Okay, what does that mean? That means all atoms should be surrounded by 8 electrons, right? The octet is atoms will gain, lose, or share electrons in order to have 8. When they gain and lose, we're forming ionic bonds. Now we're showing how they are shared in order so that each element can get its 8 valence electrons and have a stable configuration or structure, okay? Now, there are always exceptions in chemistry. Hydrogen does not get an octet. Okay, it's too small for 8, but only 2 electrons max. Right? That's why you can never put hydrogen in the center. Some other elements will get less than 8, boron and beryllium. Only 6. I'm not even going to write 6. So I'm just 4. And some elements get more than 8. And what we call that is an expanded octet. And if you get less than 8, we call that a sub less than 8 octet, suboctet. Okay, now let's just go up here. So once again, we added all of our valence electrons available for bonding, and we got 32 electrons. We're now going to arrange them. Take the same approach every time. Let's connect our central atom with our terminal, our outer atoms. So I just connected them. You can see that as 1, 2 electrons being shared, right? We're going to share 2 electrons here. We're going to share 2 electrons here. We're going to share 2 electrons here. So we have just shared a total of 8 electrons. That leaves me with a remaining of 24 electrons. Okay. I'm just making sure I did my math right. 2, 4, 6, 8, 10, 12, 14, 26 electrons. Something's wrong with my math. No, let's just go 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I just reused, I did not have a problem, all of my remaining electrons. None of them are left over. And this one always works out well. So let's look at this and make sure that we don't need to make double bonds, triple bonds, or move anything around. Let's make sure everyone's octet is satisfied. So let's look at this chlorine atom and let's count the electrons around him. He's got 2, 4, 6, and then these 2. So he's got 8. He's happy. Let's look at the other carbon, or the chlorine rather, and let's count the electrons around him. He's got 2, 4, 6, 8. Okay, he's good. Let's look at another chlorine, this guy, and let's count the electrons around him. He's got 2, 4, 6, and 8. Great. And we can easily see that our other chlorine over here will also have an octet with 8 electrons. Now, when we look at our central atom, don't forget to look at the central atom. He's right here. And he has 2, 4, 6, 8. So what we have here is a structure like this. For our carbon tetrachloride. And there we go. I've used all my 32 electrons, no more, no less. Let's do another one. Let's do, let me think of one we should do here. SO3 2 negative. Let's do the sulfite ion. Right, this is covalently bonded with a charge. Let's add up our electrons. S has 6. We have 3 oxygens. Each has 6. And we have gained 2 electrons to give us a -2 charge. It's a total of 26 electrons. All right. Let's arrange our elements. We will put sulfur in the center. And we will put oxygen around him. Like this. Okay, we'll connect the center to the outer using 2, 4, 6 electrons. So out of my 26, I use 6 and 20 remain. Let's satisfy the octet for the outer elements. 2, 4, 6 gives him a total of 8. 2, 4, 6 gives him a total of 8, and 2, 4, 6 gives that oxygen a total of 8. I'm left with 2 more. I'll put them here. And what you should see is that every element has 8 electrons surrounding him. 2, 4, 6, 8 for the oxygen. 2, 4, 6, 8 for the oxygen. 2, 4, 6, 8 for the oxygen, and 2, 4, 6, 8 for the sulfur. These electrons here are shared and belong to both the sulfur and the oxygen. And what we have here is a non-bonding pair. Okay. All right, let's do one more. This time let's do NH4+. Right, so N donates 5 because he's got 5 valence electrons. We've got 4 hydrogen, each donates 1. And we have a positive charge, so we've lost an electron. All right, so that's 4 plus 5 is 9, minus 1 is 8 electrons available for bonding. Remember, hydrogen will never be in the center. Nitrogen, hydrogen, 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 hydrogen. Okay. I'm going to connect 2, 4, 6, 8. I just used 8 electrons. I'm out of electrons. I can't add any more electrons, right? You can only use what you're given. No more, no less. Let's look at the octets here. Hydrogen has 2. Well, remember, hydrogen only wants 2. Hydrogen never has more than 2. That's it. Perfect. 2 for hydrogen, 2 for hydrogen, 2 for hydrogen. Perfect. And then what we have here is nitrogen with 2, 4, 6, 8. Now, because this has a charge, I'm going to put brackets around it, and I'm going to put the charge outside of those brackets. So I should do the same up here. Remember, this SO3 has a charge of 2 negative, so I should put brackets around it, and I should put a 2 negative charge. All right, let's look at one more. Let's look at SO3 without the charge. So this is sulfur trioxide. Sulfur donates 6. We have 3 oxygens that each donate 6. That's 18 plus 6 equals 24 electrons. Sulfur will be in the center, and we'll put the oxygens around here, okay? Connect 2, 4, 6. 24 minus 6 means 18 electrons are available. 2, 4, 6, 8, 10, 12, 14, 16, 18. Minus 18, I'm out of electrons. Check your elements. Oxygen here has 2, 4, 6, 8. Good. Oxygen here has 2, 4, 6, 8. Good. Oxygen here has 2, 4, 6, 8. Good. However, let me get rid of all those. If you look at sulfur, sulfur only has 2, 4, 6. So we're not finished. And I cannot just add electrons because I don't have any more electrons. So what happens is we need to have one of these oxygen atoms share, right? We need to say, hey, oxygen, why don't you get rid of those 2? Instead of having them as a lone pair, why don't you share them here? And now you see that sulfur has 8 and oxygen still has 8. Okay? So what you might be thinking, or maybe should be thinking, is I'm going to get rid of the highlighters because that's the answer. That's the, oh, let me finish it. That's the answer right there, right? However, you might be thinking, well, Ms. Murphy, why did you pick that oxygen? Couldn't you have picked the other oxygen? And my answer would be yes. As a matter of fact, I should have drawn it 3 times, and in every time, I should change the oxygen. Because the double bond is not just with one oxygen. It actually resonates throughout the structure and is present in all bonding sites, okay? So the double bond is not just present in between one sulfur and one oxygen, it resonates throughout. So the correct Lewis structure for sulfur trioxide would be all 3 of these, showing how the double bond right here resonates through all 3 of the bonding sites. We will continue this on our next class because students often get confused, and we'll look at this and this way and then kind of elaborate on it and maybe look at some more tricky examples. Okay, so I'm going to go ahead and end that. I didn't want this to be too long.